Hello everyone and welcome back. In this video, we will explore the concept of manometry and understand how to determine the pressure in a manometer. Today, we're going to solve a problem involving two oil tanks connected through a manometer. Here's our problem. Two oil tanks are connected to each other through a manometer. If the difference between the mercury levels in the two arms is 81 centimeters, we need to determine the pressure difference between the two tanks. The densities of oil and mercury are 800 kilograms per cubic meter and 13,600 kilograms per cubic meter, respectively. But before we solve this, let's briefly talk about the concept behind this problem. So, what exactly is a manometer? A manometer is a device used to measure the pressure difference between 2 points, typically in a contained gas or liquid system. It's a very useful tool in both industrial and laboratory settings. Here is an example of a manometer. A manometer usually consists of a U-shaped glass tube partially filled with a liquid, such as mercury or oil. The choice of liquid depends on the specific application and the pressure range being measured. When you connect the two ends of the U-tube to the 2 points where you want to measure the pressure difference, the liquid inside the tube will move. If the pressure is higher on one side, it will push the liquid down in that arm and up in the other arm. As a result, one side of the tube will have a higher liquid level, while the other side will have a lower liquid level. The difference in height of the liquid in the two arms of the tube directly indicates the pressure difference between the 2 points. This height difference often denoted as H, and after measuring the height difference between the two liquid columns, we will use it in our calculations to determine the pressure difference by using the principle of hydrostatic equilibrium. Therefore, the pressure at any point in a fluid at rest is given by the equation of P is equal to Rho times G times H, which is P stands for pressure. Rho represents the density of the liquid, G is the acceleration due to gravity, and H is the height of the liquid column. Then, this equation can be used in our problem to calculate the pressure difference between the 2 points. Now, let's see how we can solve this. In the diagram, we have two tanks with oil at pressures, which are the P sub 1 and the P sub 2. The manometer connecting the tanks contains mercury, and the difference in mercury levels is 81 centimeters. The oil column in the right tank is 25 centimeters high. To set up our equation, start with the pressure at the bottom of tank 1, then move along the tube by adding or subtracting the hydrostatic pressure terms until we reach the bottom of tank 2, where the pressure is. So, the equation we have is the pressure sub 1 plus the density of oil, times the acceleration due to gravity, times the addition of the height of the oil column, and the difference in mercury levels, minus the density of mercury, times G, times H sub 2, and also minus the density of oil times G, times H sub 1, equal to pressure sub 2. First, we identify the given values for the equation, in which the density of the oil is 800 kilograms per cubic meter. The density of mercury is 13,600 kilograms per cubic meter, and the given acceleration due to gravity is 9.81 meters per second squared. Next, the height of the oil column is 25 centimeters. To convert this into a meter, we simply divided it by 100, and the result is 0.25 meters. Lastly, the height difference in mercury levels is 81 centimeters, and also, we divided it by 100 to get 0.81 meters. Next, let's combine like terms to simplify the equation. We can rewrite it as pressure sub 1 plus the density of oil, times G, times the H sub 1, and also plus the density of oil, times G, times the H sub 2, minus the density of mercury, times G, times H sub 2, and also minus the density of oil, times G, times H sub 1, equal to pressure sub 2. Then the pressure sub 2 will be moved to the side where the pressure sub 1. And notice that the hydrostatic pressure due to the oil column, or H sub 1, appears to have positive and negative, so we can cancel it out, and then factor out on both terms the gravity times H sub 2. Now we have the equation for the pressure difference between the two tanks. The pressure difference is equal to the difference in densities between mercury and oil, multiplied by the acceleration due to gravity, and the height difference of the mercury levels. Finally, let's substitute the given values into our equation. So we have the difference in density, which is 13,600 kilograms per cubic meter minus 800 kilograms per cubic meter, multiplied by 9.81 meters per second squared, and then multiplied by 0.81 meters. Multiplying these together gives us 101,707.68 pascals. To convert this into kilopascals, we simply divide it by 1,000, and the result is 101.71 kilopascals. So, the pressure difference between the two tanks is 101.71 kilopascals. Thank you all for watching. See you next time.